Uh-oh. You know what that means. You know what time it is. We know what time it is. We all know what time it is. All right, welcome back, everybody. So, your first exam is out there. Again, take your time with it. Chapters 1 through 4, 50 multiple choice questions. Again, there's no time limit. Just don't click the button before you've answered all the questions, because I will say, nope, you don't get a second chance at it. So take your time with it, watch videos, do whatever you have to do to make it happen. All right, so today, just as a disclaimer, I usually have a lot more equipment for this than I am going to have for this lecture. And also, I usually have a lot more room to walk around, but thanks to the camera situation, I'm going to have to stay up here and point at things. I will try to walk around as much as I can. I usually walk around a lot during this presentation, but since I'm somewhat limited with what I have, I'm going to just do what I'm going to do. All right, so the system unit. We talked about the system unit before. There are several different types of system units. There's the desktop, there's the laptop or the notebook. We talked about that. There's the tablet. I know I'm missing something. There's the wearable. And there's the smartphone, right? I guess the smartphone is its own category. So there are your 5 types of system units. All right, so when you're buying a computer, there are several different things you need to take into consideration. And this is going to link to the extra credit activity for today's chapter. So sometimes we're looking at speed, we're looking at capacity, that is how much can the system unit hold, and flexibility. And that is, how many upgrades can we make to the system unit itself? Some of you are like, well, how do I upgrade a smartphone? Great question, isn't it? How do I upgrade my wearable device? It's like in some cases you have to buy a new one, right? You got to get a new one and get rid of the old one, or trade it in. So anyway, knowledge of the computer's power allows you to make better buying decisions and to determine if your current system will run new applications. I do get students in my classes that don't have a powerful enough computer to run some of the applications that our CIS program requires. So, and also they run out of hard disk space, they run out of secondary storage space, and they can't install it at all. They can't use it at all. So, again, having this knowledge will help you make better buying decisions. So, again, I mentioned all the system unit types before. The ones that are sitting in front of you are called all-in-one units, unless you have your laptop out. So behind your laptops, there's an all-in-one unit. That's what these are. So it contains the motherboard, it contains the whole computer and the monitor all in one unit. We also have plenty of different laptops that are out there. You all have, I don't know if any 2 of you have the same exact one in this class, but you all have different ones. They're all there. We've got gaming notebooks out there as well. Tablets. So here's the thing about tablets. Your book talks about mini tablets, but what size are tablets becoming now? They're not getting smaller, they're getting much bigger, right? So we can perform artwork on them now. We can do a lot more with them than we could before. And I have talked about various mobile devices as well, so let's move on. So here are the 5 different system unit types. You will notice that they have 3 main similarities. The first is that they all have some kind of system board in it, or motherboard in it. I'll talk about those in detail in just a few moments. They all have microprocessors, or as we call that, the brain of the computer. And they all have memory. I'm not talking about secondary storage space, I'm talking about memory. There's a difference between the two. I'll talk about that in just a moment. So, now to begin. So I have to have an example of what I'm talking about. So, people online, I'm going to be walking around during this, so unfortunately you're not going to be able to see me. I'm going that way. All right, so the system board, or the motherboard, or the main board, they're all synonymous terms. They control the communications between all of the devices that are either plugged into the motherboard, and also controls communications between the central processing unit, memory, and all the other components that are on this motherboard. Keep in mind that the motherboard also serves as a series of data paths and traffic monitors, meaning that there's always traffic happening throughout the motherboard. As soon as you turn the device on, the data starts moving all over the place in here at very, very, very rapid speeds. The system board has two main components. First, there's sockets. So for example, the central processing unit, which is this square here, and usually has a massive fan over it, like this. This goes over it. Why do I need a fan?
So that it doesn't overheat.
Right, exactly, because these parts get really hot, right? So the square that you see here is the central processing unit, which I will talk about in just a minute. I don't want to get ahead of myself, but I'll talk about it in a minute. But it's attached to the motherboard through a socket. So these are connection points for chips. There are also little black chips all over the motherboard. They're all over it. I used to walk up and down. I'm not doing that since I don't have much room. So we also have chips, which are tiny circuit boards that are etched onto squares of silicon. So that's what they're made of. So silicon chips, semiconductors, integrated circuits, they're all over this motherboard. Sometimes you'll find chips mounted on what is called a chip carrier, which you see up on the screen. This one does not have one, but that's what they look like. All right, we also have slots, which you will see that this card here is plugged into a, come on baby, where is it? There it goes. Into a slot. So the slots allow or provide connections for specialized cards or circuit boards that expand the capabilities of the computer. Because yes, that's what all these little slots are for that you see on the motherboard. It's so that we can plug in cards into them. Bus lines, which you cannot see unless you get up real close to it, there are lines that run all over the motherboard. We call these bus lines. And these provide pathways that support communications among all the components that are attached to the system board, or the motherboard. All right, now time for the processor. So, the microprocessor, or the CPU, again, it's been the same shape for many decades. It's a square chip. It's there. Talked about the need for the fan because, yes, CPUs can get really, really hot. Keep in mind it is contained in a singular chip. It's also known as the microprocessor. It is the brains of the computer. So if that chip gets damaged, well, poof, your device will not work if it does not have a brain. Or it will turn on, but you just can't get anywhere with it. There are two main components of a central processing unit, and these are the control unit and the arithmetic logic unit. The control unit directs the flow between the memory, which is here, and the arithmetic logic unit. It also controls the flow between the central processing unit and all the input-output devices that you can plug into the system board. The word arithmetic, I hope you know what this means. I really hope you know what this means. We're talking about what? Like addition, subtraction, Multiplication, right, or division. We're talking about math, right? So keep in mind that the central processing unit, or the microprocessor, can make, I can't even put it into terms, make calculations really, really, really fast. And that's what this arithmetic logic unit does. So those are the two main components of a microprocessor. Now, when we're talking about the chip itself, the square chip, they're measured in what we call word sizes. So you can have a 16-bit chip, a 32-bit chip, a 64-bit chip. So this is the number of bits that can be processed at one time. Just to let you know, when you type a letter, single letter, that's 1 byte, composed of 8 bits. Okay, 8 bits, 1 byte. And you need to know this for today's quiz because one of the questions has you do that math. So 8 bits equals 1 byte. So a 64-bit processor can process 8 bytes at a time, whereas a 32-bit processor can process 4 bytes at a time, or half the bytes at one time. No, there's no 128. I get that goofy question all the time. So in Windows 11, yes, you can check that. And normally, if you buy a computer nowadays, like a brand new one, it's always going to be a 64-bit processor. Macs, as I mentioned in the previous chapter, the operating system now no longer supports 32-bit applications, and it is a 64-bit processor. Now Windows, on the other hand, if you have a 64-bit processor, it still allows for 32-bit programs that are out there, applications that are out there. Another term you're going to hear about when it comes to central processing units or microprocessors is clock speed. Now keep in mind, you and I just talked about this, CPUs can get hot, and they can get really, really hot, and they require a fan. Some, I don't want to say some geeks out there, I'm going to call them geeks anyway because I am one too, so I get to say that. So there are some geeks out there that are like, well, my processor's too slow, and I need to make it faster. So they take this processing speed, that could go up to the quadrillionths of a second. Yes, that's how fast. Yes, that's how fast it can get. But they like to overclock their CPU. The problem with that is you run the risk of what if you're going to overclock it? You run the risk of, yes, I heard it all. Damaging, ruining, corrupting, I like the word corrupting. Corrupting the CPU, which means that, guess what? You got to go get another one. So just keep that in mind that I recommend, wholeheartedly recommend, to not overclock your CPU. Of course, I did try that on the Raspberry Pi once, but again, I still wouldn't recommend that. Okay, now usually I have like a board to draw on right now, but guess what? I'm not going to draw on the board. So now, that little square that you saw, the CPU, the chip, I want you to picture that square, okay? Just picture this. We have to envision things in this room because I have nowhere to write. Can somebody install a whiteboard in here? A second whiteboard so I can like show you this visually. So picture the square, okay? CPUs have been squares forever. Oh, that's right, I can come up here and do this. So think about this. I know you all run more than one application at the same time. So again, I want you to envision this. Every chip now is pretty much a multi-core processor. Some of them can get up to over 20 cores. There's like 32 core ones out there. But each core acts as its own separate central processing unit inside the chip. So I'm going to give you a basic example. Let's say I have a cheap quad core processor. And quad means 4. So we'll split that into 4 pieces. So maybe I have Microsoft Word open in one. I have, I don't know, OBS Studio in another because I have to stream. Then maybe I'm going to play the game that I'm streaming. I'm going to need that application open in another core. And then maybe I need some music playing. I have another application I want to use for that. So it opens in the other core. So it opens the applications in each core using something called parallel processing. So as each application opens, it gets delegated to a specific core. No, you don't dictate which core it goes to. The CPU does. And so keep in mind that you can have more and more and more applications open, but through parallel processing, that's how they get allocated. Allocate is the word I was looking for, to each core of the processor. So again, the more cores in your processor, the higher the cost of the computer. So if you're like, hey, I really like that 16-core processor, well, think about how much that's going to cost. So the other thing I like to talk about in this specific lecture is I just want you to have awareness. This is more about awareness. Like, I always ask people, what do you really need it for? What do you need the computer for? My last computer, $499, and I can stream on it. I can do everything I want to on it, but I don't need it to do anything else. I just need to be able to play games on it, stream on it, and all the reviews said, you can't stream using this computer, it's horrible. I'll tell you what, I take that laptop everywhere, and it works just fine. So I'm just going to tell you, you don't have to have expensive stuff to make it work. But the question is, what do you really need the device for? What do you need it for? Just like phones, right? They keep calling me, telling me, hey, you're eligible for an upgrade. And I tell them, I don't want the upgrade. My phone's just fine. So, there you go. Moving on. All right, gaming people. So, some of us who have gaming towers, like me, we need something called a graphics coprocessor or a graphics processing unit. So usually, I would also have an example of that here in this class to show people, but I don't. So I have pictures. So anyway, the great thing about a graphics coprocessor or graphics processing unit, think about the central processing unit and how much it has to work to open all the applications. The graphics processing unit takes the pressure off of the CPU. It adds more memory. It adds more memory to the computer and allows graphics to move around smoothly instead of just with the central processing unit. So some people are like, I don't need the graphics card. I'll use the integrated card that comes with the motherboard. Then you start running things and you find out, uh-oh, this isn't that good, right? It's not that good. So I need a graphics coprocessor. So the great thing about desktops, I've said this before, you can add cards like this to the motherboard. You can put it into the slot on the motherboard and add it. But like with laptops, however, when you're buying a laptop, you can't like just change it out. Okay, I'm just letting you know this. So when you're shopping for a laptop, you really do need to take some of that into consideration. What are you going to use it for? I always ask that question. What do you really need it for? Now anyway, these are great too. During COVID times, these were going for like thousands of dollars. Now, they're starting to come down a little bit. All right, moving on. Ah, yes, memory. It's pretty, isn't it? Memory. You can't see any of the chips though, right? You like the cover? You like the cover that's on this thing? Like I can throw it, and I can like hit it on the table. It's not going to break or anything. So anyhow, memory. I'm going to talk about memory next. So I'll put that down. So the memory is the holding area for data, instructions, and information. Sometimes memory are chips connected to the system board. However, these are also connected to the system board through slots, which I'll talk about in just a minute. There are three types of memory. There's random access memory, RAM, read-only memory, ROM, and flash memory. And if you're wondering what each type is, we're going to talk about it right now. All right. So notice you do not see the chips on this RAM module right here. You don't see them because they're covered. So these chips are on both sides of the board. And keep in mind that memory is volatile. So I've said this several times already. So as we open up applications, the memory gets used. As we close the applications, the memory becomes free to use for other applications that we need to open. Please keep in mind that these are also called dual inline memory modules, DIMMs. So yes, there's chips on one side and there's chips on the other, but some come with a nice little cover so that you don't damage it. Another thing too is when you install memory, I'm giving you this tip because I have messed this up several times over the course of my career. So I'm going to tell you something. When you're putting memory into the slots, it has to make a noise. It has to make, wait for it. Did you hear that? It has to make a clicking sound. I've installed memory so many times just to find out when I turn the computer back on, it's not recognizing the memory. Then I go open it up, and it's like up on one side, and I'm like, really? I'm like, really? Then I can't get my fingers down in there because there's all kinds of stuff covering this. So I have to get like a little pencil, like a pencil eraser, and like push it in there until I hear the click. And I'm like, oh, I'm so embarrassed. I must have done that like 5 or 6 times over the course of my career, at least. But that's memory. They can get now. Keep in mind that once your memory runs out, your hard disk, your secondary storage, starts becoming used for what is called virtual memory. So virtual memory can go up into the terabytes. If you have a terabyte, hard drive, then that's how much virtual memory you actually have. So it starts using the hard drive. So when we talk about solid state storage in chapter 7, that's 2 weeks from today, you will see that yes, they can get up into the multiple terabytes, and with solid state, there's no moving parts either, so that memory can just helps your performance on your computer even more. Oh, and virtual memory is one of the answers for the quiz today. Okay, moving on. ROM. So on every motherboard, there is a chip, yes, the ROM chip, that cannot be changed. It stores information by the manufacturer. It allows the computer to start up. It allows the computer to access memory. And it also allows for keyboard input. In the old days, when you would turn on your computer, you would see all these words start flashing across the screen, including the keyboard input, how much memory is on. So that's the ROM starting up before you actually got to your start screen. Okay, flash memory. So on this motherboard, there's a little box here that says gigabyte on it. It's a blue little square that says gigabyte on it. This is the flash memory. So for those people in here that know what BIOS is, and we've never had to use that, that's the basic input-output system. You should only really need to use that if you're in some serious trouble these days. That's the only time you're ever going to use BIOS. But it allows you to change like the system time. It allows you to change what drive, when you first turn the computer on, which drive letter is going to boot first. So I've had to do it to where the CD, the DVD or the CD has to boot so that I can install the operating system. I've done that with USB flash. I've done that with the USB ports also, where it has to run first, run the flash drive first before the operating system. So sometimes you do have to go into that BIOS, but it will tell you the amount of memory, it will tell you all the devices that are connected to the computer. But keep in mind that this little gigabyte square that's on here is what is called a chipset. And it has this on here so that it protects the chipset that is underneath. Just like you'll see in older, like that picture I have up here, on older motherboards, it was actually like a true box. It was actually like a box that was on the motherboard. But nowadays, it's a lot more slim. It's a lot more streamlined now. All right, so I might have mentioned this before, but the motherboard has a lot of different slots on it where you can expand your system. There are memory cards. You saw those. You saw me put memory in. Graphics cards. Talked about that. There are sound cards. So again, for people that want better sound, you're going to purchase either a sound card on your own and install it, or you're going to buy it with the sound card in it. Network interface cards are starting to become a thing of the past because now accessing networks are built into the motherboard now. So we don't really need network interface cards anymore, but they look like this. And no, that is not a telephone jack, that is an Ethernet. Yes, I've broken one of those before, thinking that it was a telephone. I kept shoving it in there going, how come this isn't fitting right? And then all of a sudden I broke it. My friend's like, great. He's like, I gotta teach you. You can't do that. I'm like, okay, sorry. So anyhow, yeah, oh yeah, I've had a lot of fun things happen over the course of my career with hardware. I love hardware. But anyway, you don't see these anymore either, but wireless network cards for like laptops, yeah, back in the day they had that slot in there and you just push it in and it would light up and you're like, okay, I can access the network now. But yeah, it's pretty much all built in now to laptops and smartphones and wearable devices. We don't have to really worry about that a whole lot anymore. All right, I talked about bus lines earlier. They run all through the motherboard. And they connect the CPU, the central processing unit, to all of the other components on the board itself. These are pathways for bits representing data and instructions. So as I said before, the motherboard itself acts as a traffic monitor, and there's a bunch of data paths that run all through that motherboard. There are a lot of them. There are many. And keep in mind that when you if you want to know the number of bits that can travel simultaneously down the bus lines, we call that the bus width. The only way you're going to find that out is to essentially go to the manufacturer's website for the motherboard, and you can get all kinds of technical specs from that. Architecture and design of the bus lines are tied to the speed and the power of the computer. So on that motherboard, it all depends how fast everything is as to what the architecture and design looks like of those bus lines. Because you're going to notice that bus lines are different on different devices. And there are two basic categories of bus lines. For some of you, you're already like, he's going to talk about USB, isn't he? Yeah, it's coming, because that's the universal serial bus. So that, you know I'm going to talk about that. So we have system buses that connect the CPU to the memory, and expansion buses which connect the CPU to the other components. So I'm talking about is, again, CPU to memory, and then CPU to all the other components on the motherboard. But you and I deal a lot with expansion buses. We deal with plugging things into our computers. We all deal with that. So the universal serial bus is the most popular one. Keep in mind that we are in 3.0 now and not 2.0. Usually those ports will be blue for USB 3.0. They will be black for USB 2.0. There is a speed difference between the two. If you try to plug a USB 2.0 device into a 3.0, the speed is going to be what? If I plug a 2.0 into a 3.0, what's the...
Flow.
It's going to be the 2.0, right, because that's what the device is. So when you're off buying flash drives, please buy the 3.0 ones. Don't do what some people do and go, oh, I got it so cheap. And then you look at it and you go, oh, it's a 2.0, huh? I'm like, too bad. So keep in mind that usually it's a blue... here they are. They're right here, right above my finger. So those are the blue USB ports that I'm talking about. So these are the 3.0s. So on most motherboards, you're going to see those. Of course, you notice there's two next to it that are the 2.0s, right next to the blue ones, right above my fingers. So, yes. So keep in mind that if you have a 3.0 device and you plug it into a 2.0 port, the speed is only going to be the 2. So the colors have to match. If the colors don't match, then you're probably going to be running on 2.0. But if the colors match, blue to blue, it's going to run on 3.0. It's faster transfer speeds is what that does. Firewire is also used for audio and video equipment, and it's more of like a shield. It looks more like a shield shape as opposed to rectangular shape. And Firewire, again, we have to have that really fast speed because we're transferring audio and video, and you all know how much how much space that can chew up. Those are big files. Those are big time files. So we need that. On the motherboard itself, talked about these slots already. Here it is. It says PCI Express 3.0, right? There are words right next to the slots. That's how I know what this is. So with PCI Express, there's a difference between PCI Express and USB. Let me go back to USB for a minute. So if you plug, let's say even one device. If you plug one device into a USB port, please note that that port is sharing the speed with all the other USB devices you have plugged into the computer. So keep in mind that those USB devices can become slow if you have a lot of them plugged into your machine. However, PCI Express has its own dedicated line, meaning it's not sharing the speed with any other device except for the card, that one card that's been plugged in, and that's it. So USB, as I said up here, USB shares the paths with the other USB devices. PCI, which is the card, has its own dedicated path, so the speeds will be a lot faster. So I thought about this because I use USB for my internet connection. Yes, on my gaming laptop. I use it, it has the little antenna on it, and I plug it in, and poof, I get, it works. But if I had the card inside, that'd probably be a lot faster. Just food for thought. All right, ports. So you gotta like envision there's like a box around this, and you can only see the outside of this. So USB ports that I just showed you, those are on the outside, or allow you to connect devices to the outside of or from the outside of the system unit. Keep in mind there are many different types of ports, which I'll talk about in a minute. There are standard ports, and there are specialized ports. And keep in mind, if you add cards to the slots, you're probably going to get more ports. Especially like for when you put a graphics card in there, you're going to get HDMI ports, you're going to get very specialized ports that you can use. And here are the standard ports. So, in the early teachings of this class, HDMI was not considered a standard port. And I never knew why, because we had high definition multimedia interface. So we could get rid of the red, yellow, and white cables that we used to have to use. Now we have it all through one cable, and that's the HDMI cable. Oh, I do have the example. Okay, there it is. So yes, so now we have the red, white, and yellow cables all in one. And we can plug that directly into... Don't mess this up, Nick. This isn't your stuff. Don't mess this up. Well, I've done this lecture 1,000 times. Okay, so we can plug it into the port, right, and connect it to the TV or connect it to whatever you're going to connect it to. My computer is connected to my TV with this, so I can have a nice 4K experience, which is what we should be doing. Anyway, there's other ports out there, like the Ethernet port, also known as the RJ45 port. Ah, there's my example. It's on this card right here. So there you go. So Ethernet ports look like that. And then I don't have it on here, but Thunderbolt. So many people have asked me about Thunderbolt. All I'm going to tell you is that Thunderbolt, in my experiences, has been really awesome. Like it's fast. I think it's faster than USB 3.0. You can connect up to 7 devices through one port and have those same speeds. Unlike USB. So if you ever buy a Thunderbolt device, it's probably going to cost you more than most likely buying something with USB 3.0 because of the speed. There are many specialized ports as well. One of these is the answer on your quiz today. That's MIDI. MIDI's been around forever. Musical Instrument Digital Interface. That's been around since like the early 90s. I want to say it's even been around before then. But I was always fascinated with that in the early 90s. I'm like, this is cool. Okay. Like it's music. But there's no words. Anyhow, you can also connect many hard drives or many secondary storage devices using, it's down here in the corner, you can connect a whole bunch of drives to this through the External Serial Advanced Technology Attachment, or eSATA ports. Those are also on the motherboard, so you can connect many hard drives or many hard disks to one computer. The DisplayPort, mini DisplayPort, allows us to connect to large monitors. VGA and DVI, those have been around forever. So wait, does this have the VGA? Oh my gosh, it has both. Okay, this has the HDMI on it too, so this is why I love using this one. So you'll see the blue and the white ports that I got my finger under right now. The blue one is the VGA port. Video graphics adapter port. We used to have those for our old cathode ray tube monitors. And then the DVI, or digital video interface port, is the white one down here. And that was for digital monitors. So again, video graphics adapter for ancient monitors, and then DVI for more newer monitors, but not what we have now. Now we're using HDMI. Then I talked about FireWire earlier as well. Oh, just for fun, here's some other stuff. So I used to quiz everybody on this. I don't now. So no, that's not PlayStation 2 ports. Wait, does this have the? Oh, it does. Way down here in the bottom, way down here in the corner above my finger, you'll see it. It's like a combo PS2 port. It's got the green and it's got the purple. So, and that's for really old mice and really old keyboards. I love this motherboard. It's got old and new. No wonder whoever let me borrow this uses it or lets me use it so much. But anyway, it's got everything on here. The floppy disk drive connector. I think this one has it too. I'm gonna look. Oh man, it doesn't have the floppy disk drive connector. But if you don't know what a floppy disk is, we'll talk about that in Chapter 7. Other ports that you would see, the parallel port, this one doesn't have one, and the serial port, so you could plug in printers for parallel ports, mice with serial ports. Also, you'll see serial ports on the backs of older servers. You'll see that as well. And then the IDE port for hard drives. So if nobody remembers this and nobody cares, I'm going to talk about it anyway. So we used to have to connect hard drives with a massive gray cable that would plug into, and it'd be a big gray cable. And those are for IDE hard drives. Yes, I used to have one a long time ago, and I'm like, good God, that was ancient. I'm not going to talk about cables a whole lot. Just please don't make the mistake of trying to put one into another, like trying to put your HDMI cable somewhere where it's not supposed to go on your computer. Please plug it into the HDMI port. I'm just letting you know that. This is going to be a record for me. I thought it was going to be 40 minutes. Oh, we're right at 40 minutes. Power supplies. Oh, yeah. So anyway, there are also power supplies. Now keep in mind, on a desktop, these are going to be a lot larger than on your phones. Because yes, we can charge our phones wirelessly now. We don't even have to. I did last night. I put it on the little thing and it charged all night, nice and slow. 100% when I woke up. It was great. But anyhow, computers require what is called direct current power, converting the alternating current, or AC, from the wall outlets or batteries. So we used to have these things, well, we still do now, AC adapters, especially for our laptops, right? Got to be able to take that alternating current, the AC, and turn it into DC. Okay, for those about to rock, we salute you. No? Anyway, moving on. Moving on. But anyway, we need power. So you notice on this part plugs into the wall. This part is connected to the motherboard. No, I'm not going to try to do that right now. But that's how that works. Alright. Computers, you're going to hear me talk about this several times the rest of the way out. Computers recognize digital signals. They do not recognize analog signals. Our voices are analog signals. The only way that the computer or our phones, especially when we talk to text, are going to understand that is by a conversion of our analog voices to a digital signal that the computer understands. So please keep that in mind. There has to be that conversion. So our devices understand what is called binary code. Again, I would sit here and draw on the board, but I cannot. I love giving the example of this. So now I just want you to picture this again. With binary code, there's only two numbers that it can be. 0 for off or 1 for ons. They can be all zeros, all ones, or a combination of those numbers. But the problem with the binary code system is it only allows you to have 256 characters. That's 0 to 255. So if they're all 0, the number is 0. I want you just to picture this. 1, 2, 4, 8, 16, 32, 64, 128. If you add all those numbers up, they're all ones. it goes to 255. If they're all 0, it's 0. So you count that number also, and then you have a maximum number of characters of 256. That is what we call the American Standard Code for Information Interchange, or ASCII, which I will show you on the next slide. And now we have a hexadecimal system that is used by computers. And those are 0 through 9, A through F. And that's over 16.7 million. Yes, you can look it up. Over 16.7 million possible characters, emojis, different languages, you name it. But the hexadecimal system, yes, definitely supports all devices now. If you take CIS133DA, the web development class, you're definitely going to learn about what hexadecimal is. All right, and it cannot go beyond letter F. It goes A through F. There's no G, there's no H, there's no I. All right, moving on. So for character encoding, again, 0 to 255 is ASCII. We were restricted to 256 characters, and that was it. That was all we could use. Mainframes use extended binary coded decimal interchange code, and pretty much all of our devices now use something called Unicode, which goes up to 16 bits. All right, this has to be a record for how fast I got through this. Usually I'm at least over an hour. We're only at 40 minutes. Holy smokes. Okay, well, I guess that gives me time to get all the equipment back to my office and get the video uploaded. All right, so our career in IT for this week is the computer technician, certifications and communication skills. But it depends what organization you go to work for. A lot of them now do require some kind of degree, unfortunately, but we have classes that teach this stuff, that teach how to put computers together. Continued education, of course, is definitely required because, well, technology changes, right? So you got to learn about all that. And the annual median salary is $61,550, which means that 50% of that is above that number. So it's a pretty decent career. I know people that are in it, they love it. Like, yeah, I love troubleshooting computers. This is great. But of course, you got to get your hands messy and stuff too. So you got to work with these things. And yes, you can get injured working with these things too, because there are a lot of pins underneath the motherboard, and that's why I'm glad that this guy put the board underneath, so I would stop cutting my hand every time I was holding this. I've been using this motherboard for a while, but he was nice and put an actual board underneath it, so I wouldn't injure myself like I've done before. All right. I'll look to the future for the chapter. We're already there, wearable computers. We're already there. We do all this stuff already. We watch our email, we send messages, we run apps all the time. All the time. Interesting that the book talks about it, though. And that's pretty much it for chapter 5. If I had a lot more equipment with me, that would probably have gone a lot longer, because I could have shown you all the different types of machines. But hey, we're here now. So all right, thank you everybody online for attending. Appreciate you. You have a wonderful rest of your day. And hey, we start Excel on Thursday. See you later.